Good morning, everyone.
Hello. Oh, yeah, we're good.
Welcome, everyone. So this is a session, Garage to Boardroom, Scaling AI Innovation. So this is kind of Gareth's session that I've tagged along with. So we've both been working in the background on a number of things in our labs. So we're just going to talk about sort of a little bit of our AI journey and how kind of we've gone through that, some of the learnings we've got, and how potentially that has sort of corporate/enterprise applications. So a little bit about us. Do you want to introduce yourself, Gareth?
Yeah, I'm Gareth Edwards. Day-to-day, I am a solution architect working with corporate and enterprise customers across the VCF division. And then I decided, much like James, that I'm going to specialize in AI and have a bit of fun along the way.
Yeah. Thanks, Gareth. So, yeah, I'm James Kilby. I work in the hyperscaler team, so I look after the VMware based on AWS solutions within the VMware stack. So, where did we begin? How did we get here? So, obviously, you will have heard it here today. You basically hear it everywhere at the moment, AI. But we wanted to kind of have a bit of a better understanding of it. Obviously, ChatGPT is the famous one. There are lots of other models available. But it's just a website, and you don't really have an understanding of what's going on. And also, there are some requirements that we sort of wanted to understand. Data privacy being one of them. So I was doing a little bit of coding, and I'm not a professional coder. There were keys and secrets and other bits and pieces that I didn't want to publicly share. So how do I keep that data private? Also, how to contain the costs. If you're using public AI engines, it's a bit like the sort of the drugs. The first one's always free. They get you hooked on the, oh, this is great, and then you've gone through your quota for the month in about 3 days, and you have to pony up your credit card. So we had a financial requirement. How do we contain the costs on that? And then both of us are very much in the server landscape. We both run big labs at home, and what could we learn from this? What could we understand? And also, what fun could we have along the way? So Gareth and my journey started a little bit differently. So Gareth started with this, and I'll let him explain it, because I'm not sure what's going on.
So some of you may have seen this at other well-known user cons. This is my AI assistant called Rana. So she actually uses my voice to text. She then runs that through an LLM, goes off to a RAG database, and basically responds to my queries. She's a glorified, well-known device. But the nice thing with this is I can use local data to get her to do things. And while I was going on this whole AI journey, she's kind of like the end epiphany, but there's loads of things I did with this, like with stable diffusion and other things. And this was all done on a Windows VM. So this was very much, I'm a developer trying to develop apps, but it wasn't scalable. And some of these apps would conflict. Even just looking up here, you see local host and a port number. Quite a lot of these apps use that same port. So I couldn't share that with someone. You'd have to log into the VM. And my instant thing was, oh, I can't scale this, and I can't go share this with friends, family. And how do I make something like this enterprise-ready? How do I get from developer to enterprise-ready apps?
Thanks. And my story was slightly different. So mine was obviously based on ESX, same as Gareth. You'll hear it, and it's almost a key requirement that you have a GPU. It's kind of, it almost goes without saying. There are some modern Intel processors that can do some things without it, but generally you need a GPU for that sort of processing, the GPU memory, and what is usually of critical importance is the GPU memory bandwidth. So my journey started with a single ESXi host, and I passed a NVIDIA data center card, here's the prop, into the host. You can see that here. Running an Ubuntu VM with that entire card passed into it, a container runtime, in my case it was Docker, and then the NVIDIA container toolkit on top of it. Now you'll see, obviously this is a data center card. Doesn't come with any cooling, hence the 3D printed things in there. These are available for about £80 to £100 now. So the actual barrier of entry of learning this stuff is really quite low at a commercial basis. Obviously, the enterprise and newer cards are significantly more than that, but it doesn't have to be a barrier. You can start really low, and you can get some really effective use cases. I've then gone on that journey a little bit more. Obviously, in this picture, you can see there were 2 of these, which was the next iteration. And then I spent a little bit more money and got a larger card, so 24 gig of RAM. Physically, it's much bigger, and the cooling requirements on this are dramatically higher. So again, it's a data center card. It's supposed to be in a server with high airflow. At the moment, the solution to keep it working is a bit hacky. But I also changed the stack slightly. So in this particular case, I'm using vGPU. So that is it's often found in Horizon stacks, where I'm actually effectively time slicing the card, or I have the capability of time slicing the card and passing it into multiple virtual machines. Ubuntu is then using a different driver, and that's the one where you need to obtain that from NVIDIA directly, and the associated licensing that goes with that. So the cost of that is much higher, although trial licenses from NVIDIA are available. The layer above that, the container runtime and the container toolkit are the same. And it's actually interchangeable, so I didn't have to change my applications when I changed between the two. And that's kind of the stack I built. One of the things that was a huge learning curve for me is how brittle this stack is. There are some layers that I've left off just for sort of display purposes, but when you see them all, you actually kind of find out that it's quite a brittle stack. What I mean by that is the whole stack has to align for it to function correctly. So if you patch ESX without doing the GPU driver, there's potentially a problem. If you change Docker versions, again, you may have a problem. Container runtime as well, and some of the Python libraries and other bits and pieces as well. So getting that to a working state, I found quite difficult. And I've actually began the process of automating the entire deployment with Ansible to get that repeatable way of having that stack deployed. I'll talk about a couple of the applications that I'm using with an AI model. So the center component there is Olama, which is the bit that's doing the heavy lifting for me. So that's the Docker container that's integrating with the GPU. On the left-hand side is an application called OpenWebUI, which is effectively a web front end for controlling those models. I'll also talk a little bit about searching as well. That's that bottom left container. And then on the right-hand side is a different application stack I use called Hoarder. And when we come to do demos, I'll just show a little bit about them.
Is it me next?
Yep.
So I can take this one step further. You probably hear the buzzword private AI, how to do it with VCF. And while we were tinkering, I literally went, OK, I'm going to go back to basics. I've been helping customers with this, but how do I get started on this journey? So the biggest thing is learning to, well, this wasn't it, is we found that we needed business requirements. So I came up with my fictional business vAnime, just like I would with any other business, and go, well, what are you trying to achieve? Everyone goes, I want to do AI. So I said, OK, the quickest thing I found is like, right, let's list out a few things that you want to achieve. Mine, a bit like James's, we both have a chatbot engine. Mine, I'm just going to use it for idea generation, but you'll see James's in a demo. You can use it. It's pretty flexible. You can use it for pretty much anything. I use mine for artwork generation as well, so I just want to model some ideas. There's a plethora of artwork generation things now, so we'll show you how we can swap out apps quickly. One thing that we do kind of come across is the ability to showcase that output. How do you deliver that content to your end users? You know, private AI is actually really only one step of the journey, is what we both find is, once you've done it, how do you get it to those users? And then, like, for me, I've just been playing with a few things. You know, you'll hear people say RAG databases. Most of you probably have a smartwatch on your wrist. I've been taking that data from my smartwatch, dumping it in a RAG database, and then maybe asking the chatbot, how can I enhance my training plan? Is my nutrition correct? So can you start using this to do different things within the workforce as well? And unfortunately, there's 0.5 on here as well, is ROI. James already touched on it. I am a tight dad. I have multiple kids in my house, and when they all come to saying, I want ChatGPT, it's about $200 per child now, I think. Yeah, that was gone. No way. So I thought, well, how can I get this to a point where I can give them something running very, very quickly? Much like James, we toyed with different cards. I've got the T4. His lovely prop here is the P4.
P4, yeah.
So big, newer and older. But you can see here, he's absolutely right. You can pick them up for about 80, 96 including, including
they're about £100 now.
And you can see, again, same problem. 3D printed little fan to keep it cold. But that whole unit there was circa, I think, 1,200 quid by the time I finished. But then that's only a couple of months of ChatGPT running, or not even that really. By the time it's 3 plus mine, that's $800 worth of licensing in a month. That's nearly paid for itself. And then I've got it for the rest of the year and a learning tool as well. James already touched on it. I'm going to caveat this because I forgot a disclaimer slide at the beginning. These are our opinions, not necessarily that of our employers. We like tinkering. We are engineers. We are like you. We like to see if we can break stuff. And this is just to prove, actually, it's so easy just to create a normal VM like you would do, attach it as a PCI device, and very, very quickly, if you install the drivers correctly, as James said, the brittle bit, that whole card is passed through. There is very, very much a zero. There's not really any barrier to entry, is there? As long as you can get it cooling, you're all good. This is where I go on to the next bit here. Otherwise, you get this. You will get lots of scratchy heads going, something's not working, something's not deploying, it's not working, and you get, it doesn't really know what's happened to the card. And essentially what this...
You've cooked it.
I've cooked it. This is the point where my card got to about 103 degrees.
Yeah.
And it just basically, VMware just evacuates the PCI card from the VM, and it just goes...
Yeah, I've had it actually reboot the host because I cooked the card so hard.
So, yeah. So this will work. Do not use this in production.
Yeah.
We are feeding back to engineering, ironically, going, people are going to try this, maybe get the error logs.
Better error messages.
Better error handling.
The other thing is, obviously, with direct pass-through, which is what Gareth did and what I did as an initial step, you don't need a data center card. If any of you are gamers and have an NVIDIA card, you can pass that through. You can use the open source drivers. There's no requirement for licensing on that. Obviously, you can only pass it into a single VM, and there are some other limitations, but you can get 99% of what we get with that without requiring an expensive card.
I have flicked to the next slide, but we do want to put a point on doing it at PCI where you do lose some really cool features, and that's where our Learning 1 came in, is one big feature you miss, which we both miss hard, no snapshots are available when you put through a PCI pass-through card.
While it's powered on.
While it's powered on. So be warned, if you are clicking, breaking, being engineering like we are, you have to shut down the VM, take a snapshot, bring it back up before you go doing certain destructive tasks.
Yeah.
And if you are fortunate like us, when we've had moments, you have multiple cards, multiple hosts. vMotion is a big no-no with PCI pass-through. So that's why the caveat is this: do not use this in production. But if you were just trying to use this to spin up a POC, or maybe even just trying to, show your business what you can do.
As a learning exercise.
Yeah, as a learning exercise. Go back to them and say, we could use GPUs. This is not ready for production, but at least can show your business the value that it can provide to help you with your paperwork. You can actually have live demos running in front of your board.
Yeah. Yeah. To do it properly, you need to spend a lot of money, but to do a POC is actually fairly low cost. So.
Yeah. I say the correct way, I've got to say this is the officially supported way, is using the vGPUs. There is also other benefits to this. As James said, you can slice up the card. Some of the other cards as well, which we'll get onto shortly, is you can maybe connect the cards as well. So if you have multiple cards, there are different things you can do. And you can see here on the right-hand side, this is a screenshot. You're going to hear everyone go VCF9. I hate to say it, this is one of my favorite features. Because you can see how often that card is used. So if you do start splitting it up, you can see in your environment what is being used by the cards in your estate very, very quickly. Yeah, Learning 2, because I appreciate we're whittling on. If you look at both these cards, they both look really, really good. And if you look at the one on the left, you would probably say, go on this one. It's not always the best card. I love this card because I'm very fortunate to have this, and I can run some really amazing models. But it actually misses some key features from the one on the right-hand side. This is kind of like the F1 car, and then this is, shall I say, the very, very fast sports car. We learned this as well as, you saw Rana, she was running on a Windows VM. When you use this big card, you can only use certain operating systems, which we'll get onto shortly. You can only also have certain feature sets which may not be available in the Docker container. So when you're looking at your cards as well, do check to your business, because maybe the one on the right, they might want to do certain artwork generation or pass that through to a Windows VM. Some developers aren't even ready for that pipeline journey. We're just maybe trendsetters and throwing ourselves in the deep end, but understand what your business is. Are they deploying a Windows VM to then get it into a Docker container? And if you look at this baby card that you saw a few seconds ago, this has even more features. So I've got some Tensor feature sets as well. So do really look at what the cards have available to them before you go and make that choice. And this is pretty much the first headache. Someone's nodding at me because he was on a call with me about this, is that really big card, which I absolutely love, and I can throw my models at it. I spent, 3 hours, because I even phoned you up, going, I can't get it to work. Can't get it to work. Realizing when you get between certain series of NVIDIA cards, not all drivers are equal. Some drivers do not support Windows whatsoever. So I'm sat there trying to pass this through to a Windows VM going, it's broken, everything's right, we've done everything via Ansible playbooks, it should just work, to then realize that the last hurdle is that A series and H series we've pretty much established are a big no-no on Windows. There are a few that are supported, but short of it is be very careful with the driver sets. And again, that as you look at your architecture, how many cards do you have in a cluster? Don't try and mix and match them, because you might get some issues with the drivers further down the line.
Yeah. If you understand your use case, and then choose the cards based on that.
I'm very much like James. I've kind of tried doing this as a pretty picture. I've got my ESXi host on the left, built on Ubuntu VM. You probably heard all the, I think, again, we must have been looking to the future somehow. We chose Ubuntu by fluke. You might have heard some of the announcements. You can kind of see, maybe we just thought we were just lucky that we knew where direction of stuff was going. Much like James, I've got Portainer on top, which is, again, he's been an absolute superstar helping me through. Linked it to my GitHub, and then I deployed my first 3 apps. The one at the top is actually something called Cheshire Cat. It's essentially Open Web UI, which you'll see. I just wanted to make it a bit more kid-friendly. And then, again, Cloudflare goes off and does lots of clever stuff for certificates that talks into traffic and makes everything much easier. It goes back to my original point of, if I've got loads of services on the same ports, it doesn't matter now. I can just grab a certificate, push it to that load balancer, and just keep clicking away. Going on to delivery of content, I then started generating a manga. I was writing a manga of all things. I then tried deploying this via something called Comga. Couldn't get on with it. I then went to, I think that's Kavita. Again, couldn't get on with it. And then settled on something called Calibra. Because, again, I wanted some of my friends to read my artwork, and I could actually deliver that to Kobos and Amazon devices. So, again, I'm producing all this content and getting it, this is the first part, and there's other bits to consider with the private AI as well, is how do you get that out to your end users? I then went even further into the rabbit hole, deploying something called Restreamer, an Owncast, because maybe we're here at the VMUGs and we need to pivot and actually have I can't use brands, can I? Should we say a well-known streaming service to stream that webcast out? So that's another way that I can do it. So I've actually now got this hosted within it, and actually I can use the spare GPU cycles to encode that video. So those cards just aren't used for AI. AI can also mean video encoding and decoding. As you'll see here, there's something called ETV, which I'll show you a demo of later, which is basically taking some of that content and turning it into a virtual TV channel. And then Bezel, which we probably shouldn't talk about. You meant to use VROPs. We're here at VMwareUserGroup. But do you understand that some of your developers may already have other apps that you can bring in? And you want to go off to your demos first, don't you? So I will.
Yeah. So as I mentioned on one of the earlier slides, so this is me logged in to Open Web UI. It's very much a chat engine. We've got a number of models here. So these are the ones that are I've pulled locally. So these exist on the server. They've obviously got a name, a version, and then the number at the end, so the 8B or the 32B, is effectively the size of the context of the model. What you're effectively looking to do is find a model that fits in the vGPU RAM that you have. So for the initial card, the P4, which I started with, there's 8 gig of RAM. So you're looking for a model that effectively fits in that. What NVIDIA does is it will split that model into slices, and it will try and run as many slices as it can within the GPU RAM. There are certain applications and processes that will still run within the CPU and a RAM of the virtual machine itself. An important thing to understand is the implications of this on your infrastructure. So at the moment, I've got Llama 3.18B as my default, and there are other models available. Code Llama as an example. When I ask it a question, so let's say when was VMware founded? It'd be better if I could spell. So this is, oh, sorry, 1 second. Live demos. So at the moment, this should just do a local lookup using the model. And you can see that was quite a fast response there. So that was processed locally using the Llama 3.18b model. That model was already preloaded in RAM, so the GPU had that model sat there ready to go. If I select a different model, let's go Gemma 3, and ask it the same question, there's going to be a pause, and that pause is because it's got to take effectively an 8 gigabyte file, read that from disk, get it into the GPU memory before it can even start processing. Now that was relatively quick because it's come off NVMe storage into the card. I can show you what 32 gig would look like, but you kind of get the idea. So one of the things that you'll have to realize if you want to go to a production level is because Gareth and mine are sort of single-use labs, we can kind of control that, or we understand that implication. If you have lots of users and lots of models available, you potentially have this huge I/O task and also overlapping AI. So Gareth mentioned Bezel temporarily. So this is Bezel running against the Docker container that's processing this. So you can see here there was a big I/O spike as it loaded that model, and you can see there was a CPU. And originally there was about 6 gig of RAM in use, and because we've now got 2 models loaded, we're now using 10.82. So if I was to ask a question again, it would give a quicker response. So that model is purely local. There's no internet access, nothing at all. One of the other tools that I've got integrated with OpenWebUI is something called searching, which is effectively an AI web proxy engine. So if I go and turn web search on here, when I ask it a question, what it's going to do first of all is take my question, use AI to break it down into a question that is more suitable for AI/search engines. It's going to then pass that over to a number of search engines to execute that query, and then it's going to take their responses and then use AI again to summarize that for me. So I'm trying to think. Nice, easy one, but you can see there, searching the web. So it's gone into 2 different search streams. It's passed that over. It's then gone on 4 sites. It's showing me the data, but I've also got the sources so you can reference it. So a lot of people will talk about AI hallucinations where you ask it questions and it's made up an answer and you don't know whether it's correct or not. Well, this is kind of almost like a halfway in between. I used AI to optimize the question, and then it's validated that they've come back with the same answer and then displayed it in a summary for me. You can then go sort of 1 step further and add files. So I use it for helping me write Docker container files. So I will pass it a file, ask it to either summarize it or sometimes document it. So we share config between us occasionally, and I will potentially ask it to go and add a summary into it or document it before I give it to Gareth. And a lot of what I'm doing, not everything yet, is published in GitHub that's publicly accessible. So if you want to kind of follow the journey that I'm going and look at the Ansible builds of how I'm getting the automation to build this stack, most of that's publicly available, and I do aim to sort of complete that journey by the end of the year.
One other little side note, just because I have to do it because of who we work for. Bezel actually uses some of the Telegraph agent as well, so everything you do with Bezel, you can do in VROPS, ironically. So, it's one of the things, just remembering this is about a journey. So work we developers understand the tools they're using and move forward. And sometimes maybe find the best of both worlds. Maybe if you are giving a proportion of that environment to your users, maybe Bezel is great for them because they can monitor that GPU themselves, and when there's a problem, they can then pass it up to the stack to you as the IaaS platform provider. Try quickly.
Well, I was going to show you Karakeep. So the other app I talked about, the app itself has been, the name has been changed to Karakeep, but I will refer to it as Hoarder, as that's what I built. So what this is effectively a bookmark indexing tool. So you've got a number of articles where I found them interesting. So who here has a blog? Do you give me, somebody suggest a URL? So what this is going to do, we're going to pass the URL, hit save.
That's it, isn't it?
This is then going to pass it over to the Chrome container in the background, so Chrome's headless. Chrome's going to go and grab a copy of your front page. It's going to take that data, pass it to the AI engine. The AI engine is then going to read it, and what it will do is it will apply typically up to 5 tags of what it thought was useful. So based on your content, it will sort of index that. So I have an iOS app as well, but it's a great way of kind of organizing my bookmarks and things. So has it done that?
Just getting there. We're trying.
Let's come back with website and domains. That's not the... One more? Yes?
Oh, sorry, I'm just going to do the web use.
You've got a comma.
Oh, fat fingers.
Live demos, eh?
Live demos. We wouldn't be here without live demos, would we? Give it a second. Normally this works flawlessly, but
yeah.
As you can see, it's a learning journey.
The only one it doesn't work famously for is, and I haven't worked out this, is if there's like a Cloudflare or a Are You a Human on it. I haven't got past that yet, but for most things it works really, really well.
Give it a quick refresh. Still thinking. Should we come back to it later?
Yeah.
So I will quickly run through a few of my demos while we're waiting for that. So again, very much like James, I've got ChatGPT doing stuff. For my sins, I've been told I've got to get more exercise in myself, as I said. And then I've also pulled in some stats from some of my smart devices. And as you can see here, I'm just demoing off the same as James. You can see stuff coming in. And I should flick back to it in a second. Should I just forward this on? As you can see here, it's then giving me a whole race plan. Yeah, I'm nerdy. I live in a basement. I do not want to go outside. But this is trying to convince me some different things that I can do. And as you can see, they very quickly said, I don't like the meal options you've given me. And very, very quickly, it's given me a load more. As you can see here, it's just churning through data. I can see stuff going on. And the interesting for me is seeing the temperature and the power draw go up. As James said, that's the one thing we want to keep an eye on. And here, this is me then. I've got a bit of downtime, so I'm now writing a manga series, and I literally ask it to start creating me a new series. And you can see it's very, very quick here at generating ideas. And I can throw a lot of these away, so I can just go, generate me some ideas, generate some more, do some storyboarding, and then come up with the best. So you can kind of even here, you can see, I actually thought this was a really good idea. And then I've asked it to try and expand on maybe the village it's come up with, because I want to create some more narrative around that. Power. Oh yeah, I'm going to have to go around and grab my power adapter. That's a good one, isn't it? And I'll just show you this demo while I get the power adapter and James carries on with his. But as you can see here, this is one of the other things I do. I've got a load of content and loads of animes in here. And you can see down in the bottom right-hand corner, I've just branded this. And what this is doing is you're using those spare GPU clock cycles to actually generate TV. Some of you may know this event as well. And I actually now have an MTV-style TV channel running in my house. I know I get bored at home by myself, so I just have this in the background, because why not? I can have my own kind of music channel and just tune into it. I'll go grab the charger if you want to get back to them.
So a couple of other things I didn't mention with Open Web UI. So you can store prompts. So obviously, you saw me write some really, really basic prompts on weather and stuff like that. But actually, you can ask it really, really complex questions. And there are sort of public websites of almost like really thorough questions of what to ask it that you can import. So you have like a please analyze my CV, but actually a really in-depth sort of prompt. You can store that. You can have file storage. You can have multiple users. So I have an administrator where I can add and remove models, change things. You can also control it so that people can use the models, but not actually add new ones. There's lots of features available with the product, and it's now becoming extensible with, you will have heard it today, in Joe Bagley mentioned it, about MCPs, where you can have that interact with other applications through MCP protocol.
We were hoping to get 2 more people on stage speakers today, but unfortunately I think there's some airline strikes. We're hoping to get Johan and Frank over here, but they couldn't make it today. But they've got some really good tidbits, so we're going to go through some of those as well. A lot of AI developers don't have an idea of what impact it's going to have. We're going to very quickly go through some of this, because we know some of these are some good key takeaways.
Yeah, they're often familiar with, I'll just call this API, but under the hood is very hidden from them.
So we think there's a massive expectation gap. A lot of developers think there is this unlimited resource available to them, because that's what they think the cloud is. The unfortunate thing is that cloud has a credit card usually attached to it. And they think everything is just there instantly. I always jokingly say, I'm going to call a brand, it's a Netflix kind of generational thing. Everyone expects everything to be there on demand. But as cloud admins, we know we don't have a bottomless pit. It's normally an overrun pit of chaos. We've got to get stuff built, and normally there's a CapEx planning cycle to get through as well. Anything you want to add to that? So how can we kind of bridge that gap? We can start having some early conversations about size and scalability. Start asking your developers what models they'd like to run, because that can help you maybe size some of those cards in your budgetary meetings.
And also what data they want to analyze.
Yeah, is this a massive database, a data lake? Actually, is it just a couple of thousand Word files? Because those can be loaded in real time during that chat kind of context window.
Yeah. Can it be batched, or does it have to understand everything at once?
Yeah. Do you want all your business intelligence in there at once, or do you just want to go pick that out piecemeal? A big thing is to focus on dev experience. We have learned the hard way. Get them on that journey with you. Learning pipelines was a bit fun, but it's also understanding what tool sets they might have. We've settled on Portainer, because, again, we're a VMUG. We know you want to use free tools, but then you've got Argo CD as well. So there are tools out there in the VCF platform as well. And maybe just take them for a coffee, say, what are you using? Is it Jenkins, Ansible? There's so many different ones these days. There's GitHub runners. Go find out what they're running with as well. And explore FinOps for AI. Because this is one thing, is like, go see maybe what they're already running in the cloud. So when you are going to have to, unfortunately, go ask for a bit of money, go, well, actually, you're spending this amount per month. You are renting it. And when we turn that rental off, all that intelligence is gone. You've got nothing to show for it at the end. Is use those numbers to back up your conversations with the finance team, and build that into part of your cloud operating model. This is the fun one. I love this one.
Understand the DC requirements. So as you can see, even at a tiny scale, power and cooling can become quite a problem. there are certain customers that I think Gareth's worked with where they want to go down this journey and they've ordered stuff and they actually literally can't switch it on. They need to bring extra power into the rack. The amount of effectively electricity in a per rack or a per U when you have these big workloads is not something that to be underestimated. A lot of us are familiar with, you've got 40U, or X number of DL380s, etc. It'll be fine. You don't even think about it, or you might have a power cap from your data center provider, and you pay a bit more for a bigger limit. That isn't necessarily the case with these providers. There's obviously stories in the news about Tesla. Sorry, not Tesla. Was it Open? No, which one's? Sorry, Elon Musk's one, where they've got gas generators parked outside the data center because they can't get enough power from the grid to run them.
Don't underestimate. It says understand it, but I say don't also underestimate it. I think I've made the painful jump now to 100 gig networking because, again, when you're moving these models quickly, as we said, moving around 8 gig and getting it performant suddenly makes a difference.
Yeah, I mean, same journey. So most of my A stuff is processed locally because I've got, well, it's now a single card and NVMe's next to it, but obviously that has scaling limits. Obviously there are servers that can have multiple GPUs and more NVMe's, but as you get bigger and bigger, which is what some of the use cases are, especially if you need to do sort of training, you need lots of servers, lots of GPUs, but also low latency, high bandwidth networking between them. And as we are at VMUG, sort of, that's what one of the things Broadcom specializes in. They are the switch chips that they do are for Ethernet are the best in the world.
This is one of our things. Is like most developers country saying we want the biggest model available, and sometimes you got to say, well, why? And I also said, as James said, I'm working with a customer right now. I've gone, why do you want this model? Because quite often the models, it's two things I've learned is you don't always need the biggest one. It's also about the data behind it, and that's why you'll see many talks here today talking about RAG databases. That's where your business intelligence is. All the bigger models are doing is maybe finessing some of that data. They might have got some better prompts in it. Prompt engineering is actually the next big thing, in my opinion, is getting you put not so good stuff in, you'll get not so good stuff out. So maybe speak to some data scientists about prompt engineering as well. It's like, I use the common analogy, make me a pizza. And everyone's like, why? And I was like, well, because you don't know what pizza I want. And you might have just said, I'm going to give you a cheese pizza. And actually, I wanted a stone-baked crust with pepperoni, but all I've asked for is a pizza. It hasn't actually got any context of what pizza I want. So maybe when you're writing these chat prompts, is maybe get it to go back to you and saying, oh, I know you're trying to make a pizza. Could you tell me what type and flavors? Because then they're actually putting better context in to get better context out. We're going to try and run through this quickly. It's like model consumption. We've kind of touched on it a bit today. These are some of the fish slides that Frank has given us as well, is be very mindful of how big those models are to get into GPU. And you see they grow very, very, very quickly. And again, you've got to take, the sizing is on peak, not day to day. You've got to understand, like, maybe suddenly you're going to get a flurry of users because suddenly another annual report or some kind of business report has come out. You're going to size it for X, but maybe you just need to give it a bit more breathing room as well. And again, this just kind of goes through, like, as you can see, Llama 3.1, 80 billion parameters, 140 gig. There's not even many cards out there on the market that could load that into one card. You've then got to think about that scaling thing. And I actually like this slide here. You see even here, like, also you notice that there's actually a bit of a sneaky one on here, is that there's actually an AMD card that can support it. And you've got to use those NV links, and that's where the GPU and vGPU comes in, because we can start using those things to kind of bridge those cards together. As James said, we did a bit of maths with Frank and some customers. Yeah, I couldn't quite get my head around this. If any of you got an electric car, you'll actually realize that is drawing, one server alone is drawing more power than an electric car. It's quite scary. I'm going to very quickly jump back to here as well, is One tool that Johan here was at the beginning is you can actually, Gemma is the best one here, is he's actually started listing out all the different models in here. So I'm going to take 2B, for instance, and you can now say how many tokens I want, how many sessions I want, and you can see very quickly here, it recommends that I'd need some GB200s at a minimum to do this, and actually, I can't have a single GPU in a server to benchmark this, and these are the kind of ones that I would need to go out and buy. It makes me cry a little bit because I've got one of these here, and knowing that I'd want a couple of my kids running this at full pout, I'd actually need 7 of them. I'm already looking at my electric bill and crying in the corner.
Yeah.
But this tool is really, really good that if you've got a developer say, I want to use model X, you can say, well, actually, have you guys got any budget for me to buy this many cards? I appreciate we've only got a couple of minutes left, so I know we do want to flick through a few more of these. Multi-GPU configs, I kind of briefly touched on it in some of the previous slides. This is where all the really cleverness bits kind of come in, is you can kind of use the NVLink bridges. You can then kind of link across servers as well. There's different ways you can do this. So again, it's also starting to think of your architecture as well. Where do you, we always go back to this as architecture, where are your single points of failure? You can dump all your GPUs in one server, and then how do you patch, update, manage, or do you start spreading those cards between servers? You might get a little bit of a loss when it comes to loading that stuff into memory, as you saw earlier, but the benefit of that is, well, you can actually go patch your server, and all you're going to lose is maybe a few seconds on the speed. So it's understanding what your business requirements there are as well. Are you happy with the risk of dumping everything in one server, and when that server goes pop, everything's offline? Or
And it also comes back to that sort of vGPU, GPU thing. Obviously, if you're running vGPU, as I now do, technically you could vMotion that to another server, so there's no interruption to the workload. So does that AI workload have a uptime requirement? If it doesn't, then potentially GPU is an option where you make note of the host, patch it, reboot it, and you've got maybe 10, 15-minute outage. Obviously, that's getting shorter now with the quick patch.
And this kind of shows it here in the vGPU. None of us are quite posh enough yet with our modest Homelabs. But you can see here how you can kind of pass the cards through the NV switch, or use MIG profiles as well. That's something we haven't really touched on. So that's where you can kind of time slice the card again as well, or even use multiple of those cards into a single VM as well. I think this does it really well. So you can kind of, again, like with the DRS, you can do your startup orders as well, and you can also say which VMs get the lion's share of those GPUs as well. And this is just reinforcing. This is actually some of the stuff that Frank sent us over. But as you can see, you start with your Ubuntu. You'll see the canonical announcement we've done. You put your GPU settings on there, your Docker, your Conda, your PyTorch, and then your GPU driver. And on top, you can also have that pre-packaged data science container. So even if you're doing this, the full-scale private AI, you actually see everything that we've learned in the lab is very, very quickly replicatable in a true enterprise fashion.
Yeah, because I mentioned how brittle the stack was for me. Obviously, with the private AI thing that we have, we control that end stack for you. So the whole patching and management process is controlled in a way that actually every bit is validated against all the other bits.
And as Jim said, that's the best bit there, is like that VM, I kind of jokingly say it's got to be treated like cattle. You want that VM rebooting regularly because it makes sure that vGPU driver is updated at the top. And you said that is the beauty of private AIs. It's got those guardrails, make sure it gets deployed, everything is up to date correctly, and you'll have a secure and robust environment. And you can see here, we've just, your developers want easy ways of accessing this, and we just want easy ways of governing that. And hopefully through some of the screenshots today, you've seen how we've been managing and controlling that. And again, you can see here, deployment options this is the lab, like a VMUG. You've got your AI workstation, which is what you saw with Rana earlier with the Windows VM. You've again then got the Kubernetes clusters, which is where me and James are trying to get to, and actually now take these Docker containers and actually cluster them. You've then got into the model runtime where you just having those models deployed as a service, and then you've got the private AI builder where you can start building in some of those RAG databases. But I think we're pretty close to the end now, but this is by far one of my favorite slides. If you just want to break down private AI really, really quickly, as I said, like we've kind of touched on all this day. You've got the AI workstations with the Windows-style VMs. You've got the clusters. You've got the different services that can be pulled in. Vector databases, I can highly recommend catching up with Cormac's session and understanding how to deploy those databases. And then again, you've got the model gallery with Harbor that if you want to basically restrict what your users are allowed to deploy and use, that is a very key thing. Me and James don't care because we're loose cannons in our lab.
We'll just pull a model off the internet.
Yeah, off we go. Right. We don't care.
Yeah.
But I'm going to start maybe doing that with some of my end users at home, is saying with Harbor they can only deploy certain models until I'm happy with them being deployed. And you should really just quickly building this out is you've got your workload domain, your hosts, and again, you can spread hosts in a cluster. Not every host needs to have a GPU, and you can just keep building this up, your namespace, and then deploying that out all the way to the end. Oh. I'll let you guys take, I think a few people take photos of that. And then just to wrap this up, because I appreciate we're over time, is what's next for us is looking at automation with pipelines more and more so we can just very quickly put stuff into a code repo and get this building stuff up. Looking at different load balancers. You've heard about Avi today. We're playing with Ansible playbooks we've already touched on. Planning about the whole east-west stuff. How do we protect that a bit more? Because quite often I'm just doing lots of ports.
Security would have a nightmare if they saw my stack because there's effectively no control between the containers. So
yeah,
it works. It fits my use case. It isn't enterprise ready. And
then down at the bottom, one of the stretch goals I've got for myself is some of you might have seen some of my other demos where I've changed my voice live on stage. I'm trying to actually get to a point where I would be speaking now, and you could actually open an iPhone app or a web app, and you could hear my voice in a different language. I'm quite close, but as we've seen, running some of these models at scale, if you suddenly do 2 or 3 languages, it suddenly uses quite a lot of vGPU RAM, and I might need to find a very nice benefactor somewhere so I can have some new cards. But you see, it's very, very quickly to deploy stuff. And then, the lab has just got excessive. As you can see at the back, as James said, I now have 2 7-kilowatt power rails going into my lab because it has just got a bit over the top. But you see at the top, you saw that little NUC earlier. That is where I've started, and it's just grown and grown and grown. And that's pretty much us, unless anyone's got any questions.
You mentioned earlier about, if you're a gamer and you've got spare cards lying around. I have a few old GPUs that I don't use anymore. Are there any limitations to the types of GPUs that can be used in a Homelab environment?
That is a great question, and scratching the top of my head, I think it's anything with CUDA 10 and above, which is about a 1060 and above when I've done my testing. Some older ones work, but basically I've done a 2060 Super in there. I've got a friend who's done this on a 5080 Ti. Yeah. As long as you can get those CUDA drivers, you're good to go.
Yeah, the P4 that I showcased is quite an old card, so if you're a gamer, you'll have something newer than that.
So as long as the CUDA drivers come up, you're absolutely fine and ready to go. Again, that's why I joke about the Windows VM. I was running all this on a Windows VM before I migrated into the whole.
Yeah, we didn't mention it, but most of what we've showcased is NVIDIA. There are certain things that will run on non-NVIDIA cards, but it's few and far between at the moment.
You probably noticed, I very briefly mentioned it. I'm already working with people that work about other cards, such as Intel and AMD. They are on their way. I'm tinkering in my lab and upsetting engineering fairly regularly, so wait and see. Anyone else got any other questions? Or hopefully that was good, and feel free to come pick our brain.